Good evening, dear students. Hope you are doing great. I'm Umar Rishi, your mathematics mentor. First of all, let me thank all my friends who passed some beautiful appreciating words, and that's the reason I'm here again. Anyways, without further ado, let's start the video. First of all, let's start with what we read in the previous lecture. Okay, let's revise. Rational numbers are those numbers which can be represented in the form of P by Q, okay, where Q is not equivalent to 0. If this P by Q form is represented in the decimal form, then uh, decimal form, after the decimal, the number should be either repeating or terminating. Then we read what were the irrational numbers. Okay, irrational numbers are those numbers which can't be represented in the form of P by Q. If they are represented in the decimal form, then their decimal form should be neither terminating nor should be repeating. Then we discuss some irrational numbers such as root 2. Can we represent this root 2 on a number line? Yes, we can. Suppose we took a triangle of unit perpendicular and unit base, then you'll use Pythagoras theorem. It came out to be root 2, and then we transferred this triangle to the number line with unit base and unit perpendicular. This was root 2. Then we opened the compass and took this as radius and transferred this to number line. Okay. Therefore, we noted that irrational numbers can also be represented on the number line. Some more numbers. Suppose we have to draw a root 3. Okay. You'll draw perpendicular on this root 2. Sorry, you'll draw perpendicular, then join this root 2 square plus 1 square. 1 square comes out to be root 3. So then you'll take this radius and rotate this right over here. So this is the way to represent rational numbers on a number line. There's one more, irrational numbers on a number line. There's one more irrational number, pi. How can you represent it on a number line? Take a circle of unit radius. Okay, open it up, open the perimeter. You can measure it by a thread, then you can measure that on a number line. So this can also be represented on the number line. Okay, then then we discuss that rational numbers plus irrational numbers make a real number. Summation of rational numbers and irrational numbers make real numbers. All the numbers on the number line are real numbers. Okay, let me give you a graphical representation of this. Sorry. Let me give a graphical representation of this thing. Okay. All rational numbers plus irrational numbers make up real numbers. Okay. Real numbers is a superset of rational numbers and irrational numbers. And in the rational numbers, all other numbers come, okay, like integers, whole numbers, natural numbers. Let's delete it. Let's take it back. And there were some other numbers. There was a limited time previous day. That's why we didn't took those numbers. So even numbers are those numbers which are divisible by 2. Odd numbers are those numbers which are not divisible by 2. Numbers like 2, 4, 6 are even numbers, numbers like 1, 3, 5, 7 are odd numbers. Prime numbers are those numbers which have only two factors. Two factors. Is 1 a prime number? No, it's not a prime number. Okay. Is 2 a prime number? Yes, it's a prime number. It has two factors, 1 and 2 itself. Okay. Is 3 a prime number? Yes, it's a prime number. Okay. Let's know some facts about the prime numbers. 2 is the only even prime number. Okay. 3 is the first odd prime number. 1 is not a prime number. 2 2 is the first prime number. Okay. Let's discuss coprime numbers. Wait a minute. Let's know what are coprime numbers. Okay. Coprime numbers are those numbers, it's a pair of numbers or set of numbers having their HCF highest common factor equivalent to 1. Okay. Let's know some facts about coprime numbers. 1 is coprime with every number. Okay. If you place 1 with any number, they are going to be coprime to each other because their highest common factor is going to be 1. That's why they are coprime numbers. Any two prime numbers are co-prime with each other. Any place, any two, suppose 17 and 19, they are co-prime to each other. 7 and 5, they are co-prime to each other. Okay. 3 and 2, they are co-prime to each other. Any two prime numbers, when placed together, are co-prime to each other. There's one more fact about co-prime numbers. If you take two co-prime numbers and sum them up, add them up, and suppose this is an x, and if you multiply them, you get y. These two numbers will also be co-prime to each other. So that was all for today. Hope you enjoyed the video. This was not a complete lecture. This was a bit of revision to previous classes. We're going to start the syllabus of 10 from next lesson. So that was all for today. Hope you enjoyed the video. Have a nice time till next lecture. Goodbye.